Hello everyone, welcome back to Geeks, and in today's video we will be discussing about our weekly contest 181. This contest consists of 4 problems, and as compared to our previous contests we can say that this contest was a little difficult, and we will be discussing about all the problems that were there in the contest, and we will be understanding the problem statement and going through the thought process, and finally we will be understanding the solution of each problem. Now let's start with our first problem. So the name of the first problem is count trips, and here's the problem statement of our first problem. So what does the problem statement says? Sonu is a delivery guy at Alpino. He starts his day by picking up deliveries from the city center 00 and has to distribute them to multiple locations provided in locations array. Sonu can only move along a straight line from the center on each trip, meaning he must return to the center to take a different direction if other deliveries are not along in the same path. Given these constraints, determine the minimum order of trips Sonu needs to complete all deliveries in a day. So what we have a delivery guy, and he is currently standing at a point 00, right? And he has some delivery locations which are determined with the help of some different points, right? And he has to deliver to each of these locations, but here's a catch: he can only move to only one direction in a single run, right? Like if he goes to this point and when he will return, he can't go to this point directly. Firstly, he needs to return to the center 00, and then only he will be able to go to this point. After going here, he will return to center again, and then he will go to this point, and after that to the center again, and then other point. And if like in this path, 2 delivery locations are there, so he will be delivering to both of these locations. And if we have some other delivery location on the slide right or left to it, so he won't be able to deliver to this location because it doesn't falls in the straight line with this location, right? So he can move to only one direction at a time. That's what we know. Now let's see example and understand this question with the help of an example. In the example, we have given different points. First is 00, 1, 2, 2, 4, minus 3, 6, and minus 1, minus 2. So we have 5 different points. As our first point is 00, first point will take no time. Our Sonu will be able to deliver at there, as our starting point is also 00. So here I have represented all of these points in a Cartesian plane. So our first point 1, 2, here's our 1, 2. Second point 2, 4, here's our 2, 4. Minus 3, 6, here's minus 3, 6. Minus 1, 2, here's minus 1, 2. How many times should the delivery guy need to change his direction? Firstly, like say he is currently at this 00. Firstly, he will deliver to this location, and after that he will come to the center again. Firstly, he delivers to this location, and he comes to center again, and now he will deliver to this location, and after delivering to this location, he will come to the center again. And now, as we can see, the ratio of these 2 points are similar, right? As we can see, 1 by 2 equals to 2 by 4, right? This is x point of this, and this is the y point, and this is x point of this coordinate, and this is y point, right? As they are in the same ratio, they must fall in the same line. The delivery guy can deliver to these 2 locations in a single run. Total number of directions he has to change and number of paths that he will take will be 3. First for this, second for this, and third for this. And as we can see, the number who has a similar ratio, right? The points who has a similar ratio between their x and y pointers, like if some x1 upon y1 equals to x2 upon y2, then we say that they falls in the same point. And as we look at this third point, it is also equal to are these points, right? As the ratio will be 1 by 2, its ratio will be also 1 by 2, and it will also form 1 by 2. Why a Sonu is not able to deliver to this location as they're falling in the same straight line? Because the direction we have to change is from the center 00, right? So he won't be able to change his direction. He can only either go to this way or either this way. He won't be able to deliver to all these 3 points in a single run. So I hope this problem is clear now. That was our first example. Now let's see what we can do in this problem to solve this, and what are other things that we have to take care of. So now here is a Cartesian plane. Currently our delivery guy is standing at this point and the current coordinates are 0 0, but what are the different ways he can move to? So either he can move to this quadrant, this is the first quadrant, either he can move to this quadrant, this is the second, and this is third, and this is the fourth quadrant, right? Either he can move to this quadrant, or this, as they all will lie in different directions, right? He can move to different directions in this quadrant, and he can move to different directions in this quadrant, and similarly in this, and similarly in this. If point is falling in any of these quadrants, our person have to take different directions, right? No matter whether they will fall in the similar line or not, right? It is possible that one point here and one point here they falls in the same line, but still our person will need to take different routes to reach both of these points as they are in different quadrants. What we can do, firstly, we can create how many different lines with the help of points we can form in all of these quadrants. If we are able to find this, how many lines we are able to form in each quadrant, then it will be fine. And among these quadrants, our points can also fall in these axes, right? It can fall on this positive y-axis, on this positive x-axis, or this negative y-axis, or this negative x-axis, as the value for the y will be 0 and x will be 0 for this axis. So it is not feasible to take the proper ratio method for them. So we will be taking the points that are falling on these axes differently, right? We will be taking them differently, and we will be taking the points that are falling in these quadrants differently. If we somehow able to calculate how many points are falling in this first quadrant which have similar ratio, let's assume here in the first quadrant we have 5 points, and these 5 points forms 5 different ratios. Let's assume these are 1 by 2, 2 by 3, 3 by 4, and 2 by 3, and 1 by 2, right? And these 5 different points forms 5 different ratios, and we are assuming that two of these ratios are similar. What does this mean? If these ratios are similar, then we can say that these points are falling in the same line, right? So how many paths a delivery guy would need? So he will need 1, 2, and 3. Here it will be forming 3 lines in this quadrant which will be covering all these 5 points, something like this: 1, 2, and like 3. And here are 2 points, here's a 1 point, and here's are 2 points. If we are able to find the ratio of all the points that are falling in each quadrant, then it is possible to check how many points are falling in the same line. And as for if we talk about other quadrants, in the second quadrant we can also check similarly. And as we can see, in the quadrants that we have, the points that will fall in the second quadrant will never be able to form a straight line with the points that are forming in this first quadrant. We can have some point here, and if we have some point here, they will form a straight line like this. But the main thing is that our straight line or our path should always pass through the center, right? It should always pass through the center. And if we have some points in these consecutive quadrants, in these adjacent quadrants, then it is not possible for them to form a straight line which is passing through the center. And we are not talking about these axes. We will be taking the points that are falling on axis differently. What we can do, firstly we can find how many points are falling on different axes. Points on axis, we will be able to calculate that. We will be checking if our x equals to 0. If somewhere our x is 0, then a point is falling on y-axis, and according to y-axis I'll be checking if the value of y is greater than 0, then it is on positive y-axis. If the value of y is lesser than 0, then it is on negative y-axis. As for both of these y-axis, I had to take different routes, as if I have this positive y-axis and this negative y-axis. So we will need to take different routes for both of these y-axis, right? We can't go to them in a single run. If we calculate that, we will be having all the points that are falling on similar axis. And if somehow we calculate the different number of points that are falling on these two axes and these two axes, the ratio of different number of points, to be more correct, the ratio of different number of points, as these two axes will never be forming a straight line which will be passing through the origin. If we able to find the number of unique ratios of different points that are being formed, then the number of unique ratios will be equal to, it will be equal to the number of lines that will be present in our total path, right? If we calculate the number of ratios, the number of unique ratios that we have in these two quadrants, then we will be having the number of ratios, the number of lines which will be going upwards, right? And it will be covering all the points that are lying in this area. And if we count the number of unique ratios that we have in these two quadrants, then we will be having all the lines that will be covering all the points that are lying in this area. So if we are able to do that, we will be getting our answer. We will be adding all these points that are lying on these axes and number of these lines. If some point lies on x-axis, we can count it as 1. If no point lies on x-axis, like call it positive x-axis. If some points, if like 3 points are lying on positive x-axis, then we will be taking its value as 1. If no point is lying on positive x-axis, then we will be taking its value as 0. If we able to calculate these unique ratios for each of these two quadrants, then we will be able to find the number of lines that will be formed. And to count these unique ratios, what we can use set, right? We will be using set, and as these are ratios, right? These are ratios, we can use a set of double, as we have to store the numbers in the ratios can be something like 4.583. So we will be using doubles so that it won't take or it won't round off the ratios that we have, right? So I hope this is understandable and everyone got this. So let's move to the solution for this problem. So this is the solution for this problem. What we have done, we have created different sets, right? Q1, Q2, Q3, Q4. As there are two ways, either we can create 4 sets in which we will be taking all the lines that are appearing in each quadrant, right? In each quadrant, or we can create only 2 sets in which we will be checking the line appearing in these two quadrants and in these two quadrants, right? So it's not compulsory to make 4 sets, and we are creating 4 variables in which we will be checking whether our point is falling on this positive x-axis, positive y, negative x, and negative y, right? We have 4 variables in which we will be checking is there any point falling on our different axes. And now we are traversing our array. We have assigned this x, the x pointer to a variable x and the y pointer to a variable y. And now here I'm checking for positive x-axis, here I'm checking for negative x-axis, here I'm checking for positive y-axis, and here I'm checking for negative y-axis. If any point is falling on these axes, then I'm making the corresponding variable as 1. After this, I'm checking if my y is greater than 0. In case my y is greater than 0, I'm talking about these two quadrants. If y is greater than 0, then I'm inserting the ratio of my points in one of my set that I have created, set of double. As I'm using set, it will be storing only unique ratios, and I'll be finally having all the unique lines that can be formed with the points that I have in those two quadrants. And here in the next condition, I'm checking if y is lesser than 0. By lesser than 0, I'm checking for these two quadrants. If value of y is lesser than 0, then I'm checking for these two quadrants and I'm storing the ratio, right? I'm checking how many unique lines can be formed in these two quadrants, right? And at the end, I'm returning the sum of all these 4 x's if any point is falling on them. And this, I'm returning the size of these two sets that I have created. The size of these sets will be equal to the unique number of lines that are falling on these two quadrants, right? Q1 will be representing this quadrant, this quadrant, and my Q2 is representing this quadrant, right? And after that, after storing the sum of all of these, I'll be getting my final answer. That will be my required number of paths that the delivery guy has to take, right? So this was our problem 1. So now let's discuss our problem 2. And now let's see the problem statement. So what does the problem statement says? In the game of cricket, players can score runs by hitting the ball delivered at them by another player called bowler and running between designated spots called wickets. Suppose if a player is only allowed to score 1, 2, 4, and 6 runs in a ball, how many ways can the player score n runs without hitting consecutive fours? Return the answer modulo 10 raised to the power 9 plus 7. Here we have two players which are playing cricket, right? And one is a bowler, right? And other is a batsman, right? The basic game of cricket they are playing. And here the batsman can score only four types of scores: 1, 2, 4, and 6. Either the batsman will be able to score 1, 2, 4, and 6. He won't be able to score 3, and he won't be able to score 5. Like 5, it's not even in the real cricket. He won't be able to score 3. He can only score 1, 2, 4, and 6. So here we have a restriction that says without hitting consecutive fours. If on the previous ball it was a 4, then our person won't be able to score another 4, right? Like consecutive fours are not allowed in this game. So let's understand this. So what we have to find, we have given an n and we have to find how many different ways I can attain this score of n. Let's see how many ways we can score this n. So our first way will be scoring all ones, and one way can be scoring two ones and one two, one on first ball, one on second ball, and two on third ball. Similarly, it can be one on first ball, two on second ball, and one on third ball. And it can be two on first ball, one on second ball, one on third ball, right? And it can be two on first ball, two on second ball, and it can be a direct four, right? So we can score this 4 by these methods. These are total 6 methods. We can score 4 by 6 methods, right? As here our 1, 2, 4, and 6 were allowed. So there's no way getting a score of 4 after hitting a 6. So we are not considering 6 in this case, right? Here we know that a person can score these 4 scores, right? Anytime. But if a person had already scored a 4, he won't be able to score the 4 again. Then if the previous score was 4, the previous run he scored was 4, then he will be only able to score 1, 2, and 6. He won't be able to score a 4. Now let's discuss more about this problem, like how the things are working, right? Let's see. Currently our score will start from 0. Score will always start from 0, right? And how many ways we can score 0? There can be only one way to score a 0, by doing nothing. So when we are at our initial position, when our score is currently 0, we are able to hit these 4 types of score. We can hit 1, we can hit 2, we can hit 4, and we can hit 6, right? If we hit 1, we are able to hit another 1, we can hit 2, we can hit 4, we can hit 6. Similarly for the 2, we can hit 1, we can hit 2, we can hit 4, we can hit 6. But for the 4, we can hit only 1, 2, and 6, right? Because we have scored 4, we won't be able to score another 4. And in the case of 6, we can hit 1, 2, 4, and 6, right? And if I similarly go further, in this case of this one, I'll be able to score 1, 2, 4, and 6, 1, 2, 4, and 6 in this case of 2, and 1, 2, and 6 in the case of this 4, and similarly 1, 2, 4, and 6 in this, right? It will be similar for this 1, 2, 4, 6, 1, 2, 4, 6, and similarly 1, 2, and 6 for this. So 1, 2, 4, 6, 1, 2, 4, 6, right? So I can see I have two types of conditions here. In one, when I am able to score 1, 2, 4, and 6, and in another, when my previous score was 4, I'm able to score only 1, 2, and 6. These are the two types of scores that I'm able to score. If I have to find in how many ways I can reach to a score of n, right? If I can reach to a score of 6 in like 7 ways, right? This is not the exact amount I'm taking. Let's take another example. We took the example of 4 previously, right? So we can score 4 in 6 different ways, right? And as for the 4, now we know we can score this 4 in 6 different ways. And now if we have to check for how many different ways we can hit 5, and let's say we can only hit a 1, we are allowed to hit a 1 only. In how many ways we can hit this 5? If we are allowed to hit only 1, if 6 ways we can hit 4, then the only choice we have to score a 1 in all these 6 cases. So if we are only able to hit a 1, then it will be 6. But if I say if we can hit 2 also, then we will be able to score the number of ways we can hit 4, right? If we can score either 1 or either 2, then by scoring 1 after a 4, I can reach this 5. So the number of ways in which I can hit 4, and for the 2, as 5 minus 2 is 3. To hit a 5, to get a 5 after hitting 2, my previous score needs to be a 3. So if I finds out how many ways I can find a 3, I can score a 3, that will be equal to the number of ways I can hit a 5 with 2's at the last, right? So let's see in how many ways we can hit a 3. So 3 we can hit in like 1 1 1 is one method, 1 2 is another method, 2 1 is another method. Is there any method else? No. We can hit 3 in 3 ways. It will be number of ways I can hit 4 plus the number of ways I can hit 3, right? If only 1 and 2 are allowed, because if I am scoring 1, my previous score needs to be 4, and if I'm scoring a 2, if I'm hitting a 2, then a previous score needs to be a 3 to get a 5. So if only 1 and 2 are allowed, then it will be the number of ways of 4, it is 6, and the number of ways of 3, it is 3, right? It will be a total of 9. And similarly, as I can either hit 4 and either hit 6, so there's no possible way to take this 6 as 4 is 4. If currently I am hitting a 4, right, and I need to get an output of 5, so what's my previous number needs to be? Yes, my previous number needs to be 1, right? So if I am taking this 4 into account, I'll be adding the number of ways in which I can hit a 1. The number of ways in which I can hit a 1 are only 1, right? By scoring a single score, I will be able to hit a 1. So it will be 6 plus 3 plus 1, which makes a total of 10, right? So it will be the output for this 5. Similarly for the 6, how many ways I can hit a 6? The number of ways I can hit a 5 for the score of 1, number of ways I can hit a 5, number of ways I can hit a 4 for the score 2, number of ways I can hit a 2, because 6 minus 4 equals to 2, right? If I am hitting a 4 and I want to reach to 6, then the previous number needs to be 2 plus the number of ways I need to get a 0, right? It will be giving me the output for the number of ways I need to score a 6, because if I'm directly hitting a 6, how many ways there can be? What will be my previous number? My previous number needs to be a 6 minus 6, which is 0. So number of ways of 5, it was 10. Number of ways of 4, it was 6. Number of ways of 2, we have calculated it somewhere. Number of ways of 2, it will be 1 1 and 2, right? It will be 2. And number of ways of 0, there's only one way of getting a 0, by doing nothing, by scoring nothing. So by this we will be able to get the number of ways we can score. So it will be 16 plus 2 18 and 19. In this way the problem arises when the number becomes bigger, like if we have to find something for like a 24, so we can't directly check for the previous 4. So what we can do, we will be storing all the ways in an array, right? We will be creating an array in which we will be having two arrays of size n, in which we can store all the ways we can score up to, like we have to score 24. So we will be having two arrays of size n plus 1, right? And in this we will be storing the number of ways we need to score the score at particular index. The number of ways we can score 0, the number of ways we can score 1, the number of ways we can score 2, and similarly 3 and 4. So why we created this array of two size? Why we created these two arrays? In the second array, we will be storing if my previous score was 4. How can I reach to this score, this particular score, with by scoring a 4? If we want to check for a 4, we need to only consider those ways in which my previous score was not a 4. Let's go deeper and understand it. Here we will be finding the number of ways we can score a 8. So what we have done up to now, we have created an array of size 2, and it is containing n plus 1 elements, right? It is of n plus 1 size. So what we can do here initially, how many ways we can score 0, right? We can score 0 in a single way. Let's assume at the 0th index of I, the main size of our array is, it can store n plus 1 and 2, right? This is the size of our array. What are the different ways we can score a 0? It is 1, and at this position I'm storing the number of ways I can score without hitting a 4, and at this position I'll be storing the number of ways I can score the particular score by hitting a 4. So in how many ways I can get a 0 by hitting a 4? Yes, there's no way I can get a 0 after hitting a 4. In how many ways I can get a 1? By checking in how many ways I can get a 0, because after 0 I can score 1. There's only one way to get a 1, by scoring a single 1. In how many ways I can get a 2? In how many ways I can get a 2? I can get a 2 by the number of ways I can get a 1 plus the number of ways I can get a 0, right? Because in this 2 I'm able to score either 1 or either 2, right? So if I'm going to score 1, my previous score needs to be 1, and if I'm going to score 2, my previous score needs to be 0. So it will be array of 1 of 0 plus array of 0 of 0. It will be 2. And in how many ways I can score this 3? I can score 3 by, if I scores 1, I need it to be a 0, and if I scores 2, it needs to be a 1. If I go for 4, it will become negative, so it is not possible, right? So it will be array of 2 of 0, array of 1 of 0, it will be 3. And similarly, I'll keep checking for how many ways I can hit a 4. So to get a 4, I can hit either 1, either 2, either 4, right? I can't hit a 6 to get a 4, right? So there are 3 methods. What will be this? If I score a 1, then a previous score needs to be a 3. So how many ways I can hit a 3? And if I score a 2, my previous score needs to be a 2. Then how many ways I can hit a 2? And if I, sorry, why I wrote a 6 here, it should be 4. Yes, if I score a 4, my previous score needs to be a 0, right? So what will it be? Its value is 3, its value is 2, and its value is 1. 3 plus 2 plus 1. I think there's some problem. Yes. Wait a minute. I'm talking about if I'm hitting a 4. There can be a total of 6 ways, but here I'll also consider this index. All the ways for up to now, it will be 0, right? I can't get a 1 by hitting 4. I can't get a 2 by hitting 4. I can't get a 3 by hitting 4, but I can get a 2 by hitting 4. Up to now, we haven't considered this 4, and in this part, we are considering only our 1, 2, and 6, and this part we are considering our 4. In how many ways I can get a 4 by hitting either 1, 2, or 6? Then its value is 3, its value is 2. I can get a 4 by hitting 1, 2, and 6 in 5 different ways. In the case of 4, I'll be doing array of 4 of 1 equals to array of 4 minus 4 of 0, right? Because in that case, my previous element needs to be not a 4. I can't consider this one. I am only able to consider this one. So here it will be 1. Similarly for this 5, I can hit this 4, I can hit this 3, I can hit this 1. So I can do that, right? So for 5, what I have 1, I have 2, and I have 4. For 5, I can hit this 4, I can hit this 3, and I can hit this 2. I can't hit this 1. And 4, 3, not this 3, not this 2, only this 1. If I score a 1, then my previous element needs to be 4. If I score a 2, then my previous element needs to be 3. And if I score a 1, if I score a 4, then my previous element needs to be 1. It will be a total of 8. And here what I'll do, I'll not take this 4 into consideration, right? I'll not take this 1 into consideration here. I'll not take this 1 into consideration here. This one will come here. And here similarly for this, I'll check for 1, 2, and 6. So for this one, I'll check for 5, and for 2, I'll check for 4, and for 6, I'll check for 0. For 5, I have 8, and for 4, I have 5. 8 plus 5, 13, and 13 plus 1, 14. For this, it will become array of 6 minus 4 of 0. It will be 2 here. And at this 7, I'll check for 7 minus 1, 7 minus 2, and 7 minus 6. Right? So at index 6, I have 14. At index 5, I have 8. And at index 1, I have 1. So it will be 15 plus 8. Is there some problem? 7 minus 6. At index 6, I have 14. And at index 5, I have 8. And at index 1, I have 1. Right? It will be 23. And similarly, I'll find this for 8. Right? And I'll end up with 36. And for this 8, what will be the 8 minus 4? It will be 4. Here it will be this 5. Here I'll be having 5. And at the end, I'll return whatever I have here. I was finding for n equals to 8. So in how many ways I can score a 8? It will be equal to 36 plus 5, which is 41. Right? So now this was the approach that we are going to follow to write the code for this problem. Right? We are going to create an array, a 2D array of size n plus 1, in which each array will be containing 2 elements, and among those 2 elements, in one we will be storing when my score was 1 to 6, and other will be storing when my score was 4. Let's check the solution. Here's a solution. So what I have done, initially I have stored my mode because my value will go into long and it will become really big. So I have stored this number for which I have to take mode in a mode variable, and now I have created a 2D vector or 2D array of size n plus 1, and I have initialized each number with 0, as currently I don't know how many ways are there to reach any score, and this will be our base case. In how many ways I can score 0? I can score 0 in only one way, and now I'm traversing the whole array, and here if I minus 1 is greater than 0, if 1 is a possible score to reach my current score, then what I'm doing, then I'm adding it's I minus 1 of 0 and I minus 1 of 1, right? Then I'm adding both of the ways in which I'm including when I have scored 1 to 6 and when I have scored 4, because my current score is 1. So I'm including both of these ways in finding my current element. So now let's come to next if condition. Now I'm checking if my I minus 2 is greater than 0. If I can score 2 to reach to my current score, right? Because if it would be 1, I can't take this 2 into account, because 1 minus 2 will be minus 1 and I can't score 2 to get a 1. So if I can score 2, then I'm considering the element that is occurring at I minus 2, and I'm taking both the conditions into account, in which I was considering 1 to 4 and in which I was considering 1 2 and 6, sorry, 1 2 and 6, and in this I'm considering the last element was 4. Similarly for the 4, in the 4 I'm only considering in which my last element was 1 2 and 6. I'm ignoring that 4, right? Because 4 is stored at the first index. Similarly for the 6, I'm checking for both the conditions, and at the last, at the end of my array will be containing the total number of ways I can score my current score, right? If it contains, if my last score was either 1 2 or 6, and this one contains the number of ways I can score if my last score was 4, this the sum of last two values of my array will be my required answer, right? So this was the solution for the problem 2. Let's discuss our problem 3 of contest 181. The name of the problem is pick apples. Let's read the problem statement. So in the problem statement, it is given that it is the apple harvest season. Alice and Bob are all set to pluck them from their farm. However, due to a certain incident, the apples are now falling down one after another. The farm is in an infinitely large 2D plane. Given the initial coordinates of Alice, ax and ay, and initial coordinates of Bob, bx, by, and also the coordinates where apples will fall. You need to calculate the minimum Manhattan distance covered in total by Alice and Bob together in order to catch all the apples. The Manhattan distance between two coordinates x1, y1 and x2, y2 is modulus of x1 minus x2 plus modulus of y1 minus y2. It can be assumed that they can reach all the distances without letting any apple fall down to the ground. Also, you need to help them catch the apples in the sequence they fall. Example, they can't catch the second apple falling before the first. In particular, it is necessary that all apples before the ith falling apple must be caught before catching the ith apple for all I in range 1 to n. So, what the question is saying, so we have two persons, Alice and Bob, and they are in a farm. So their farm is like a 2D plane. The farm is an infinite size 2D plane. What we have to do, we have to find the minimum Manhattan distance covered in total by Alice and Bob together to catch all apples, right? Here, like we have somewhere here are Alice, and here we have somewhere are Bob. Here we have some trees, right? This is a tree, this is a tree, and we can say this is a tree, and some apples are falling, and we knows the order of the apples, right? We know first here our apple will fall, and second here our apple will fall, third here our apple will fall, and fourth our apple will fall here. We have given the initial positions of Alice and Bob, and we also knows the position of the next falling apples, and as they are given in an array, the position of different apples, the apples can be only picked in their given order, right? As we have the coordinate of our first apple, and then coordinate of our second apple, and then coordinate of our third apple. If Alice wants to pick this fourth apple first, she won't be able to pick this apple, because before picking this fourth apple, we have to pick this first apple and after that first apple we will be able to pick the second, then this third, and only after that we will be able to pick this fourth apple. So we can't jump to the next apple before picking the previous apple. So before the first we have to pick first, and before the third we have to pick second. This is what the question says. Let's have a look at example. So here we have example. In the example we have given the current coordinates of Alice, which are 0 5, current coordinates of Bob, which are 2 2, and coordinates of two apples. So firstly we will be picking this apple, and secondly we will be picking this apple. So here's the representation in a graph. So this is the coordinates of Bob, these are the coordinates of Alice, and these are the coordinates of our apples. So as for the first apple, the apple with the coordinates 0 3, there can be two things. Either Alice can pick it or either Bob can pick it. So what if Alice picks this apple? Then here's the coordinates of Alice and here's the coordinates of our first apple. What will be the Manhattan distance? Manhattan distance will be modulus of 0 minus 0 plus modulus of 5 minus 3. It will be 2. And if our Bob picks first apple, then these are the coordinates of Bob, these are the coordinates of first apple. It will be 0 minus 2 plus 3 minus 2. It will be 2 plus 1, 3. And if Alice has picked the second apple, thereafter we can have two more possibilities. If Alice also picks the second apple, or either Bob picks the second apple. Now if Alice picks the second apple, now when Alice have picked our first apple, now the coordinates of Alice has changed. Now this is the coordinates of Alice. As Alice came to pick this apple, this is the new coordinates of Alice. Now what if Alice picks this apple also? Currently the Manhattan distance we found is 2 and our first apple is picked. Now we are checking for the second apple. If Alice picks the second apple, what will be the Manhattan distance? It will be this is the coordinates of Alice and these are the coordinates of second apple. These are the coordinates of Alice because when Alice picked this first apple, what happened? The position of Alice changed, right? We are considering only the our first case when Alice picked the first apple. So when Alice came here to pick this apple, the coordinates of Alice changed, and now the new coordinates of Alice are equal to the position of this first apple. What will be our new Manhattan distance of both apples when Alice also picks the second apple? It will be modulus of 2 minus 0 plus modulus of 3 minus 3. It will be 2 plus 2, which is 4. And similarly, if Alice has picked the first apple, it was 2. And now if Bob picks the second apple, the current coordinates of Bob are 2, 2, right? Because we are taking the condition in which our Alice picked the first apple and Bob hasn't moved yet. So the position of Bob is fixed. It hasn't changed. So what will be the Manhattan distance now? X1 minus x2. So 2 minus 2 plus 2 minus 3. It will be 1. So the total time, total distance, total Manhattan distance taken to pick these two apples is 3, and here it was 4. And if we also calculate for this condition, when our Bob picked first apple, then it will be greater than this 3. We will be getting something like 5 and 6, and after comparing we will be able to find that this 3 is the minimum distance which we gets when we find all the possibilities of picking the apples. In this distance 3, our Alice picked the first apple and our Bob picked the second apple. So now let's understand this problem. How can we approach with this? So here in this problem, we already saw that we have two main conditions. We have two choices. We can say we have only two ways to pick an apple, right? We can pick an apple in only two ways. Either Alice is going to pick it up or Bob will pick it up, right? And similarly, in this we will also have another choice, right? If we have more apples left, now the new apple will be picked up by either Alice or Bob, and similarly in this, Alice or Bob. So what if our Alice picks the new apple? What if our Alice picks the apple? Then the position of Alice will become equal to the position of apple, right? The position of Alice will get updated to the position of apple, and if Bob picks the current apple, then the position of Bob will get updated to the position of apple. It is clear when our Bob picks the apple, then he is moving to a new location and the location of Bob has changed, and the position of apple, the location of apple is now new location of Bob, right? Now from that position we will be checking for the next apple, and also similarly in the case of Alice, we will be checking from this position now. And after comparing all of this, now here we will be also having some Alice and Bob. We will be getting some output. It will be giving me some output. It will be giving me some output, right? The Manhattan distance it took, the Manhattan distance this took, the Manhattan distance took if Alice took this apple, and the Manhattan distance for if Bob took this apple. I think it's becoming a little bit clear. We can use recursion in this. As to solve this optimally, we are going to use memoization. We are going to implement memoization to solve this problem, right? What we are going to do, we are going to store the current position of Alice and Bob, and after that we will be checking for each condition. What if Alice picks this apple, and what if Bob picks this apple? And similarly for each step, we will be updating the position of Alice and Bob to the position of apples. And after that, we will be checking for another apple. What if Alice picks this another apple, and what if Bob picks this another apple, right? Let's understand it a little bit more. And here we have taken an example. Here we have an apples array, and we are considering that we have three apples with three different points, P1, P2, P3, and here we have the position of our Alice and Bob. Initially, we are assuming that our Alice is standing at a position A and our Bob is standing at a position B. Let's see what we have done here. Currently, these are the positions of my Alice and Bob. Currently, Alice is at a position A and Bob is at a position B. Now, we always start picking with our first apple, right? We can't start from somewhere middle because apples needs to be picked sequentially. We can't jump to next apple without picking the previous one. If our Alice picks the P1 apple, what will be the new positions? If Alice picks the P1 apple, the new positions will be P1 and B. Now this is the position of Alice and this is the position of Bob. So the Bob's position will stay same and the Alice position will get updated to the position of apple. And here it is taking some Manhattan distance, which I have took as m1. And similarly in the case of Bob, if Bob picks this apple, the position of Alice is staying same and the position of Bob is getting updated to the position of apple. And here I'm assuming it is taking some distance m2, right? Some Manhattan distance of m2. Similarly, now we will check for our second apple. Now here also we have two conditions. Alice can pick second apple or either Bob can pick second apple, right? If Alice picks, then the position of Alice will get updated and the Bob's position is staying same. And if Bob picks, then position of Bob is getting updated and the position of Alice is equal to its previous position, right? It's not equal to its initial position. Its initial position was A. It is equal to its previous position, right? Because our Alice was at P1 and now the Alice hasn't moved, but Bob has moved to the position P2. And here it has some Manhattan distance. It took some Manhattan distance. I'm taking it as m1 to B, and it has took some Manhattan distance m1 to A. Similarly, here also for the P2 apple, if Bob picked the previous apple, then there can be similarly two choices we have. If Alice picks this P2 apple, then the position of Alice is getting updated to P2, and if Bob picks this apple, then the position of Bob is getting updated to P2, right? And here the position of Alice was same, and here the position of Bob is same. Now we have our last apple, P3 apple. Similarly, here we are picking P3 apple. If Alice picks P3 apple, position of Alice is getting changed, and if Bob picks P3 apple, position of Bob is getting changed. And if Bob is picking this P3 apple, the position of Alice is same as its previous position. And here, if Alice is picking this P3 apple, the position of Alice is getting changed and position of Bob is same. And here, if Bob is picking this P3 apple, the position of Bob is getting changed and the position of Alice is same as it is. And similarly, the conditions are here. Now, after P3 apple, we will try to go into the next index, and of as the size of our array was only 3, here we will exceed our size. Here we will exceed our maximum index that we can access. This can be our base condition. If current index becomes equal to the size of my array, size of apples array, then we will be returning out of the function. Then we will be returning what will be the distance it will be taking. As there's no apple, the distance it will be taking it will be 0, and similarly from here it will try to go to the next point. As there's no next point, it will be returning 0. A distance of 0 will be taken, and now it has some Manhattan distance. Let's say it has some Manhattan distance mx, and it has some Manhattan distance my. Now it will return its Manhattan distance to this. Now it will also return its Manhattan distance to its previous call. Now it has two Manhattan distance, and at this point I'll compare these two Manhattan distances, and I'll pass the Manhattan distance which is lower. I'll pass the minimum Manhattan distance to my upper function, right? So let's assume this mx is lower, then it will pass this mx, and along with this mx, what will happen? Along with this mx, firstly it will pass this mx, and along with this mx, now this function has this mx, and it will be, this function will be also getting some Manhattan distance from these, right? It gets 0 from here, it returns 0, and it returns some Manhattan distance, it returns some Manhattan distance. Let's call it, it is getting some minimum Manhattan distance at mz, and now they also have some Manhattan distance of their own. Now what's the total Manhattan distance covered to reach to the last tuple? It was m1 to a, the current Manhattan distance, plus the next Manhattan distance which was returned to this, and what was here, the current Manhattan distance which I have taken as m1 to b, and the Manhattan distance which is returned from the next tuples up to the last. This is the Manhattan distance which is taken to reach up to rp3, right? This Manhattan distance that will be taken to reach to P3 from P2. Now it will compare both of these distances, and the lower distance will go to, both of these distances will go to our P1, and P1 will take the lower distance, and it will add the lower distance. Let's say this distance is lower, let's call it something x, and this x distance will go to its previous call, and it will be added with its current Manhattan distance, and let's say it got some y from its side, right? Similarly it will be getting all these calls. Here it gets n, my index reaches n, it will return 0, it will return some Manhattan distance, it will also return some Manhattan distance similarly here, and it will return the minimum Manhattan distance, and it will be returning in minimum Manhattan distance to this, and out of this the sum of this and sum of current Manhattan distance will be returned to our upper function, and out of these two distances our minimum will be returned to this, right? And it will be returning, like, we get some m2 plus y, and now we have two choices. If first apple is picked by Alice, then the minimum Manhattan distance that would be required to pick all the apples would be some x plus m1, and if first apple is picked by Bob, then the minimum Manhattan distance required to pick all the apples is some m2 plus y. Now out of these two distances, our minimum will be printed, will be returned. This was the basic approach. How we are going to accomplish it? We will be creating a DP array in which we will be storing the Manhattan distance that is being taken at each particular point, right? At each point, right? I and j. These are, this I and j represents the position of Alice and Bob. And as for the Alice and Bob, what we can do? We can create a new array, and this array will be containing current position of Alice, current position of Bob, and all our apples, all the points of our apples. And why this array will be containing the points of apples? As I was saying, it will be containing the position of Alice and Bob, because the position of Alice and Bob will be updated according to the position of apples, right? I think it is clear how we're going to do it, how the call will happen, and what are the two conditions we have, how we're going to calculate Manhattan distance, and out of those Manhattan distance we will be comparing Manhattan distances, and we will be returning the minimum Manhattan distance. Now let's see the solution. Here's the solution. Firstly, to calculate Manhattan distance, I have created a function which is returning absolute of x coordinates plus absolute of difference of y coordinates, right? This is our Manhattan distance. And in next point, what have I done? I have created a solve function. We will jump to this solve function later. Let's come to our main function firstly. So this is our main function which is provided to us in our IDE. So in this we have given an Alice array, a Bob array, and an array of apples. This contains coordinates of apple, and these are our initial coordinates of Bob, and these are initial coordinates of Alice. Now we have created a new vector of vector points. In this we will be storing the position of Alice, position of Bob, and position of all the apples. Now what we have done, we have pushed the initial position of Alice into our array and initial position of Bob. Now we are pushing position of all the apples in our array, and now we have created a memo array, right? A memo array of array. In this we will be storing all the position, all the Manhattan distance, all the minimum Manhattan distance that is being covered for the position of Alice and position of Bob, the minimum Manhattan distance. So I have created it for the size of the points. It is equal to the size of this array, and in this I have initialized each point with -1. Currently I don't know how much Manhattan distance will be taken for each point. Now I am calling this solve function. As for this solve function, now let's have a look at this. Here's my solve function. Here in the solve function I have passed my points array. This points array contains the position of apples and the current position of Alice and Bob. And here I have three variables, a, b, and I, and this a represents the current index in which our position of Alice exists, and this b stores the current position in which the position of our Bob exists, and this I is the current position of apple that I have to pick. Now if I equals to pointer size, return 0. This is our base case. If somewhere I reaches the end of my current array, then I'll return 0. There's no apple to access now, right? So I'll return 0. And if memo of a of b is not equals to -1, this means that I have already something for the current position of Alice and Bob, right? As a represents the position of Alice and b represents the position of Bob. If this is not equals to -1, what we have, we know that the current position of Alice and Bob is occupied, so we will return the current position what we have in the current position of Alice and Bob, as we don't want to calculate it again and again. If something is stored here, this means we already know the minimum Manhattan distance that will be covered to pick all the apples for the current position of Alice and Bob. And now we are calculating some d1. D1 contains the Manhattan distance that will be covered if the current apple is picked by Alice, right? So what I'm doing here, I am calling the Manhattan distance with the points A and points I. I'm passing the position of Alice and the position of my current apple. And what I've done after that, I am passing a points array as it is. Now the position of Alice, I'm updating it to the position of current apple. The position of Bob is staying same, and I'm checking for my next apple. I'm incrementing the I because I'll check for the next apple now. And similarly here, I have created a D2. In this D2, I'll be checking what if the current apple is picked by Bob, right? So I have calculated Manhattan distance, and I have this points array as it is. And here's the position of Alice is same, but now the position of Bob is changed. And now I'm checking for my next apple, and the array is same as it is. Now after all of this, I'll update the minimum distance that is required for the current position of Alice and Bob. It will be equal to minimum of this D1 and D2, right? So it will perform memoization and it will work on the basis of backtracking. Firstly, all the calls will happen, and then my first base case will hit, then it will return 0. So for the last apple, this solve function will return 0, and this function will now my D1 will be storing the Manhattan distance for the last apple, and after the last apple, the current position of Alice and Bob will, the memo element for the current position of Alice and Bob will get updated, right? And this will work similarly as we have discussed in the previous tree. As this was the last position, our solve function returned 0 from here, because what will be I plus 1 for the last index? It will be equal to n. That calls our base case, and similarly it returns 0 and it returns a Manhattan distance. It will compare it, return to the call above it, and it will compare similarly and it will return to the above. And finally I'll be getting some answer which will be the minimum of D1 and D2, right? That was our function. That was our whole function. Minimum of D1 and D2 will be giving me my final answer. at the end of the memo, the current position of Alice and the current position of Bob will be storing my final answer. So this was our third problem for this weekly contest. I hope everyone understood it. Here we have our fourth problem of this weekly contest, and the name of the problem is pattern count. Let's read the problem statement. So the problem statement says you have been given two strings, text and pattern. The pattern string contains only $1 character, where the dollar character can be replaced with any non-empty string. Your task is to find the count of all the substrings of text that can be formed from the pattern string. So here in this question, we have given two strings. The name of the strings, first string is our pattern string and other string is text, and our pattern strings contains only a single dollar, and besides this dollar it can be containing some other characters A, B, C, D, E, F, any character. Our text string is also contains some characters A, B, C, D, E, F. This dollar can be replaced with any substring of this text. So we can replace this dollar with this A, with this B, with this AB, or with A, B, C, D, E, F, or with this whole string, right? We can replace this dollar with any substring of this text, and we have to tell in how many substring of this text I can form after replacing this dollar with a substring. And I can't replace it with an empty substring. I can't replace it with an empty substring. So let's have a look at example. So here's our example. We have given a text ABC and the pattern string is $C. So here's a pattern string $C, and I can replace this dollar with any substring of my text. So I can replace it with A, B, or either C, or AB, BC, or ABC. I can replace with it all of these. If I replace this dollar with A, I'll be getting AAC. Is this a valid substring? No, this is not a valid substring. And if I replace this dollar with this B, I'll be getting ABC. Is this a valid substring of this text? Yes, this is a valid substring. So we have found one way. And if I replace it with C, it will be forming ACC. Is this a valid substring? No, this is not a valid substring. And if I will be replacing it with any of these, it will be making the size of my pattern array more than this text array. So this is not possible. So I can form only one substring by replacing this dollar with any substring of text. So let's discuss one more example. So here in this second example, we have given a single dollar, and I can replace this dollar with any substring of this given text. If I replace it with any given substring, if I can replace it with any given substring, what are the number of substring that I can form? As this is a single dollar, it has nothing on its left, it has nothing on its right. I have to replace it with all the substring of the given text. It will be equal to the number of substrings that the text have, because with how many substrings I can replace it with. I can replace it with G, E, E, K, S, or either GE, either GEE, either GEEK, either EE, either EEK, EK, and all the substrings of this text geeks. So what will be the total number of substrings? Total number of substrings that can be formed from by replacing this dollar with all the substring of this text geeks will be equal to the total number of substrings of this, and it will be equal to the n into n plus 1 by 2. This is the formula for this is the value of total substrings that we'll be getting, and it has plus 1, which represents the empty substring. So we are not considering empty substring here, so we won't be considering this plus 1. So the total number of substring of this is n into n plus 1 by 2, and we can replace it with any substring. So if we replace it with any substring, it will be the substring of this text. So our output will be 1 2 3 4 5 5 into 5 plus 1 by 2, which is our 15. So I hope this question is now clear. So now let's go to the approach. How are we going to do this question? So in this question, as we see, we can have a single dollar, and besides this one case, we can have 4 different cases. So let's discuss those cases. So in this first case, we had nothing to the left and nothing to the right, right? So all the characters on the left were empty, all the characters on the right were also empty. What is the total number of substrings that I can form? In this case, the total number of substrings that I can form will be equal to the total number of substrings that my text has, which is n into n plus 1 by 2, right? If my pattern substring is equals to dollar, then my total number of substrings will be n into n plus 1 by 2. This was our case 1. This was our first case. And what if we have only something at the back of our dollar sign, right? If we have something like this, and here are some characters, and the left side is empty, right? It has nothing as its prefix. Prefix, we can say prefix is empty, and it has some suffix. How many ways there can be? Let's see. So this is our text. Our text is ABCD ABC. This is our text, and the number of substrings I can find is, let's firstly we will find this BC. Let's see how many times this BC is appearing in our text. Here once and here two, right? So how many substrings I can form? If I replace this dollar with A, it will form one substring. If I replace this dollar with this A, it will form another substring. And if this DA, it will form another substring. CDA another substring, BCDA another substring, ABCDA another substring. So what are the total numbers? From this BC, I can form only one substring by replacing it with A. So for this I have one, and for this BC, how many substrings I can form? One is this, another is this, another is this, another from this B, and another from another is our whole string, right? So what are the total number? 1, 2, 3, 4, 5. I can form 5 substrings from this BC. Let's check the indexes 0, 1, 2, 3, 4, 5, 6. Right? It has its indexes from 1 to 2. Right? Our first occurrence of this suffix and our second occurrence of this suffix has its indexes from 5 to 6. I can say that if our pattern array has no prefix and only a suffix, then I can form from one occurrence of a suffix equal to the start index of our suffix, right? As it's what was its start index? Its start index was 1, right? And how many substrings I can form with this? I can only form one substring as it has only element ahead of it, right? It has only one element ahead of it, so I'll be able to form only one substring. And from this occurrence of this suffix, how many substrings I can form? I was able to form 5 substrings, which is equal to the start index of this suffix, as it has 5 elements ahead of it, 1, 2, 3, 4, 5. So I was able to form 5 substrings. In this case, how many substrings I'm able to form? I was able to form number of substring equal to sum of start indexes of suffix. This was our second case. This was our case 2. Now let's see the third case. In the third case, a third case can be when we have a prefix and our suffix is empty. When on the left there on the left we have some characters and on the right we have nothing, right? So what was our text array? Our text string was ABC DABC, right? This was our text string. Now let's see how many strings we can form from this AB dollar. So let's do the similar thing. Let's see how many times this prefix is occurring. Here it has occurred one time. Here it has occurred two times. In this case, how many substrings I can form with this AB? I can form only one substring with this AB, right? By replacing this dollar with this C, one from this AB, I can't form any other substring from this AB. So from this AB, I'm able to form one up to this C, second up to this D, third up to this A, fourth up to this B, and fifth up to this C. I was able to form 5 substring from this occurrence of this prefix, right? So total number of substrings I was able to form was 6. Now similarly, let's write the indexes 0, 1, 2, 3, 4, 5, 6. I was able to form one substring from this and 5 substring from this, and these are the indexes. Can we see a pattern here? Its index is 4 to 5, and we were able to form only one substring. The number of substrings I can form is equal to the number of elements appearing at its end, right? It has only one element after this. So the number of substring I was able to form was 1. And in this occurrence, it has 1, 2, 3, 4, 5 elements on its right. So I was able to form 5 substrings. How can we calculate the number of elements that are appearing after the occurrence of this string that we have found? It will be equal to the position of last element, position of last index, position of last index. Here, what's the position of last index? It is 5. And what's the size of this array? It is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The size of this string was 7. So the number of elements that will appear after this occurrence will be equal to the n, which is the size of this string, n minus position of last index minus 1. So how many substrings we can form by replacing this dollar with substrings? We will be able to form n minus position of, sorry, we can call index, right? Index of last element of suffix, prefix, not suffix. It's quite confusing, prefix and suffix. And we will be doing this for all the prefixes that we have. Here we had 2 prefixes, so we checked for them. And if we had another AB like here, then we would be adding more to it, right? If we had this AB, it will be adding, then what will it become? It has 7, so it will be adding 7 to this, and it will become 7 plus 5, 12. It will become 13. This was our third case. Now let's see our fourth case. In the fourth case, we have something on its left as well as something on its right. We have both prefix and suffix, and now we will check how many substrings we can form from this fourth case. So here's our text array, ABC, DABC, and this is our pattern string $C. So with how many ways I can form this a substring? By replacing this dollar with a substring. One can be this, one can be this, and other can be this, right? This A to this C, this A to this C, and this A to this C. So we will find the last element, the occurrence of this prefix, how many times this prefix occur and how many times this suffix occur, and from the last element of the suffix, right? If the suffix was something like AB, and if we had something like AB dollar DA, then what we will be doing? We will be checking the last index of this prefix and the first element of this suffix. Does they have any difference greater than 1? If their difference is greater than 1, we can surely form a subarray. But if their difference is not greater than 1, it is lesser than or equals to 1, then we won't be able to do it. Why? Because if the difference is equal to 1, then what will be? It will look something like this. Then there's no gap between them. And with what I can replace dollar? There's nothing I can replace dollar with, right? I can't replace dollar with an empty substring. So then there's no way. And if it is lesser than 1, then this means my suffix is occurring before prefix. That also doesn't make sense. I'll find the last element, last index of this prefix and first and the starting of the suffix, and I'll check what's the difference between them. If their difference is greater than 1, then I'll add them. So how many string I was able to find here? I was able to find 1. Their difference is greater than 1. Here their difference was greater than 1, and here their difference was greater than 1. So I'll increment it when I found something like this. So in this case, I found 3 occurrence, 3 substrings I can form. These were all the 4 cases that we had. Now what we have to do, in the pattern string, I'll find my prefix and suffix which we have. According to the prefix and suffix that I have, I'll implement one of these 4 conditions, right? If they are empty, then my first condition will hit. If only prefix is empty, then my second condition will hit, then my third, and then my fourth. Firstly, what I need to do, I'll find the occurrence of this. Firstly, I'll find this prefix. I'll separate out this prefix and suffix from my pattern string, and after this, I'll find this prefix and suffix in my text string, right? I'll find them in my text string. So For finding a particular string in another string, which algorithm we can use? We are going to use KMP algorithm. KMP algorithm, right? KMP algo, known as North-Morris-Pat algorithm. North-Morris-Pat algorithm, right? North-Morris. As for this question, we are directly implementing this KMP algorithm. We are not going to discuss this KMP algorithm. We're going to discuss the main conditions of this question. If you want to understand this KMP algorithm, you can try searching KMP Geeks for Geeks or KMP GFG. There you can find video for the explanation of this algorithm, right? So now let's see the solution for this problem. Here's the solution. Firstly, I would like to make it clear that here I have called a search function. In this search function, I'm calling a search function I have created in which I have used KMP algorithm, and in this search function I'll be returning whenever I'm calling this search function with a text and a pattern array. I'll be finding that pattern array in that text. I'll be finding that pattern in that text, and I'll be returning an array consisting of start indices of that pattern in that text array. If you are interested and if you don't know about this KMP algorithm and wants to know it, you can search KMP GFG on YouTube, and there will be several videos coming up and you can refer them. Let's understand this problem. So in the solution, what we have done, firstly we have created variables for the size of both the strings, and then we are finding the index of this dollar, right? We have created this IDX. Until this IDX is lesser than the size of this pattern string and this IDX is not equal to dollar, we are incrementing this IDX. At the end, our IDX will be pointing at the position of the dollar, right? If we have something like this, our IDX will be pointing at the position of the dollar, and we are creating a prefix substring. We are creating a prefix and suffix. Prefix will be from, like if we have something like this, ABC dollar DEF, prefix will be from 0 to IDX, right? It won't consider this IDX, it will be considering one before this IDX. We have implemented substring function, and this suffix will be from this IDX plus 1 up to the end of our string, right? So now I have found my suffix and prefix. Now I'm creating two arrays, start prefix and start suffix. In these I have implemented my search function that in which I have used KMP algorithm. So this search function will be returning two arrays, which is containing the start indexes of all the occurrence of prefix, which will be stored in this start prefix array, and in this start suffix array I'll be storing all the first occurrence of starting of my suffix. And now I have created one more array and prefix. As for the case of the prefix, I'll be calculating with the help of the end index of the prefix, right? In the above cases, we were calculating with the help of the end indexes that we had. Now we are running a loop in the start prefix. So what will be, how can I calculate the ending index of a prefix if I know the starting? Yes, in the starting index, if I'll add the size of the prefix, if I add the size of the prefix in the starting index, I'll get my ending index, end index, right? That's what I'm doing. In the end prefix array, I'm traversing over the start prefix array, and I'm inserting and I'm adding the size of the array, the size of the prefix string -1, right? If the size of the prefix is 7 and its starting is 0, its ending will be 6. Now I have found my end prefix array. I am creating a result. In this result, I'll be storing my final answer. If my prefix and suffix both are empty, then I'm doing n into n plus 1 by 2. This was our first case. Now our second case, if only prefix is empty, then I'm iterating over my start suffix array, start suffix string, start suffix array. Then it contains all the occurrence of suffix, right? 0, 1, 3, 5, and I'm adding these indexes to my result, right? What we have discussed, if we don't have a prefix and we have a suffix, then what we were doing, we were adding the starting index of the suffix 0, 1, 2, 3, 4, 5, 6. Here we have the starting index 2, and we will be adding 2, right? Because we can form two strings, A and B. and its starting index is 5, so we will be adding 5 because we can form 5 strings as it has 5 elements ahead of it. This was our case 2, and here's our case 3. In the case 3, I'm checking if my suffix is empty. If my suffix is empty, then I have some prefix. I'm having something like this. In that case, what I'm doing, I'm checking the ending of prefix. These are my prefix, and I'm checking the ending of prefix. So how many substrings I can form if I have this prefix. From this prefix, I'll be able to form this many substrings, right? Which is equal to the n minus last index of this, which is, let's say, I minus 1, right? Which is equal to this. So I'm checking for all the end indexes of the prefix, and I'm adding it to my res, which is my final result. For the case 4, I'll also have a case 4. I think I forgot to mention. Now here I'll be having my case 4. In the case 4, I'll be having my if condition like this. Now in the case 4, I have both suffix as well as prefix, so I'll be traversing them both. So let's create two variables, I1 and I2 equals to 0. I'll be iterating over the end prefix and start suffix array that I've created. Let's say I1 points to the start end prefix array, while I1 is less than end prefix dot size. My I2 is less than start suffix dot size. That will do. And now I'll check if the ending of prefix and starting of suffix has a difference greater than 1, right? If they have a difference greater than 1, then only I'll be able to form a substring from them. So I'll check if end prefix of I, right? I'm accessing current element minus start suffix, sorry, lesser than start suffix of I2, right? Here it will be I1 minus 1, right? If they have a difference greater than 1, then I'll be adding res plus equals to start suffix dot size minus my this I2, right? Because why this? I'll be checking how many elements I have accessed before, and I will be subtracting my current element. If my current index, if I am at the first position, if I am at the 0th index, and size of the suffix array is like 5, I have 5 more suffixes left, then I'll be able to form 5 more arrays, then it will be 5 minus 0. And if I am at the index 1 and size of the suffix is 5, then I can say I have 4 more substrings left that I can form, right? And after that, I'll be checking for the next element of my end prefix array, and if this is not possible, if they don't have a difference greater than 1, then I'll be incrementing my suffix array. I'll be going to the next element of suffix array, and I'll be checking my next element. So for that, I'll do I++, and in the end of everything, I'll return my res, which is my final answer. So this was our weekly contest 181. I hope every problem is clear. Thank you for watching.